Good afternoon, everybody. This is the first video of at least three I'm going to send today. We'll see if I can fit it in three. I've been very busy. I'm sorry I didn't get any videos out yesterday. I had lots of students needing help, and I gave them the time they needed. But it also gave me, and by extension, you all, a gift that I'm really getting to see what a student tends to get students or repeated questions that are coming up. So I'm going to focus on a couple of those from 7.2. Just one in this video, and I'll record a second video for the other. So the first one refers to this phenomenon. This isn't necessarily a question that comes up in the homework, but it's sort of a simplified version that I created to explain something that can happen. And it has to do with sometimes there being more solutions than you anticipated. So if you found that you keep solving problems in 7.2 and they say, oh, there's more solutions. This is really why that happens. So I created this. The indicator for when this will come up is that any times that you say, oh, we've got this 5t in here. So you might do this thing. Oftentimes they recommend you call that u. And that's because when you're looking, u would be the angle of rotation, but t is often, the variable used because sometimes time is a measurement related to the rotation. But it's important to keep in mind that those are two different things, and it can get confusing as, are we talking about an angle or are we talking about a measure of time? So when you call that u, it really focuses it on the angle. And then notice when they give you this specific interval, it's important to notice that that's a measure of t. And just a heads up that in the end, we're going to find these angles, but because 5t equal those angles, we're going to be dividing by 5. So the time is going to be 5 times smaller than the angle, in other words. All right, so let's bring up the drawing. I've already mapped it out for you. So here's the unit circle coming up. And this phenomenon with an angle creating a sine of -1/2 would happen in these scenarios in quadrants 4 and quadrants 3, where the y value is below, is a negative number, and compared to the hypotenuse in the unit circle, which is always 1. So the first thing I want to notice that if the solutions we want have to be between 0 and pi, neither of these solutions are between 0 and pi. Both of these solutions are between 0 and 2, or pi and 2 pi. But we're not talking about the angle u, we're talking about t being between 0 and pi. So let's find these two angles. I'm going to say, okay, let's really call it this one. The reference angle here, really related to this y length of a half, is pi over 6. Right, and we've got that in the unit circle, that pi over 6, or a 30-degree angle, will create that y length of a half. So to get to b in this case, which you can see is that reference angle past pi, you can just say pi plus pi over 6. And I tend to think of that as 6 pi over 6 plus pi over 6. That's going to be 7 pi over 6. And then there's this other angle that also works as a solution in quadrant 4. I call that B. I don't know why. Let's call this A just because I called the other one B. And we'll say A is, I would consider that short of a full rotation. It would be the reference angle less than a full rotation. So that would be 2 pi minus pi over 6. And you've done this a lot of times at this point, so I'm comfortable that you're following just fine. So I think of that as 12 pi over 6 minus pi over 6. That would be 11 pi over 6. If we bring back the t at this case, that means we've got two scenarios where 5t is either that b angle, 7 pi over 6, or 5t is 11 pi over 6. And notice when we divide both sides by 5, and I could call that, let's call it, let's instead call it multiplying both sides by 1/5. I'm kind of solving both of these at once just because they're the same algebraic steps. That's going to give us t equals 7 pi over 30 and t equals 11 pi over 30. So notice that those angles certainly, or those aren't angles, those t results for t. 7 pi over 30, if you think about that as 7/30ths pi, that's certainly less than 1 pi and more than 0. And this one also, 11 pi over 30, in fact, is less than half a pi. So you're probably going to be tempted to say, yay for me, I'm done at this point. But actually, there's more solutions to this problem. And it has to do exactly with the fact that we do this division of 5. So larger angles can actually work out to still divide by 5 and be within that range of the interval of the problem, like between 0 and pi. So let me just quickly erase these and let's check the next couple. And when I say next couple, I mean, remember that this is a periodic motion, so we can also just say, oh, well, we can I didn't do a good job of that. Starting right there, we can say we could also go all the way around and then go again back to this first place. We can also go all the way around and then again go back to the second place. In other words, the more simple way to say that is we can take our original solutions and add 2 pi to them, add a full rotation. So just quickly recall that our original solutions were 7 pi over 6 and 11 pi over 6. Well, by adding 2 pi to both of those, we could look at the next coterminal angles. So 2 pi over 6 is 12 pi over 6. We can call that 19 pi over 6. And then we could call this one 23 pi over 6. But again, those are the angles, the measures of u, not the t. So then again, we'd have to say, well, we have to look at this 5t is equal to 9 pi over 6. And 5t is equal to 23 pi over 6. And if we again multiply everything by a fifth, then we'd get this result of t equals 19 pi over 30 and t equals 23 pi over 30. Now still, 19 pi over 30 is more than a half a pi, but it's less than pi. 23 pi out of 30 is more than a half a pi, but less than pi. So both of these also fit into the original interval. Remember, we were talking about the interval 0 is between, or t is between 0 and pi. So there's 2 more solutions that work. I think that's the last of it. Why did this like disappeared? That's interesting. Oh, I got it. I think that's the last of it, but let me just check to be sure. Let's just go one more rotation. Sorry, this was from a previous write-up. Get rid of these real quick. Let's go one more rotation where we start with this smaller angle. So we had done another rotation and gotten to 19 pi over 6. And let's do another rotation of 2 pi, which is another 12 pi over 6. So that would get us to 31 pi over 6. And I'm not going to go to the next one because I think we already might be bigger than we can fit in our interval, but let's just check. So if we had 5t equals 31 pi over 6, and we multiplied both sides by 1/5, then this would become t equals 31 pi over 30. And finally, we've got an angle or a time too big to fit in our interval. So that means we have accounted for all the solutions. So I'm just telling you that because this is getting students as far as they told me there were more solutions. So I just wrote it down or I looked it up in Desmos and I saw it, but I don't really know why. This is why. It's really because when you divide by 5, in the end, when you solve for t, much, much larger angles reduce down to something that fits within that interval. So you may have to consider the next rotation or the next 2 rotations, depending on the problem. And in a general way, a good way to think of it is as soon as you step in and call something u, that there might be these other possibilities that happen based on the algebra here. when you solve for the t situation. So look out for that. All right, I'm going to stop the video and I'll be back shortly with another one.